Hi, this is a demonstration for lesson 4 on Newton's third law and the conservation of momentum. So we're going to use this track system without any data today to model the 3 examples that are in your book on pages 68 and 69. So you want to turn to this page to follow along. We're going to do simulation A, B, and C, and you can also follow along with your notes today. So in our simulation with the carts here, this will be the blue cart representing the blue train car, and this will be the red train car. So in the first example in A, we have 2 train cars with the exact same mass. In situation A, the red train car is moving at 10 meters per second and has more momentum. The blue train car is moving half the speed, only at 5 meters per second, and has half of the momentum. So what we're going to see what happens when they collide is some of the momentum from the red car is transferred into the blue car. So if you look at the picture on page 68, you can see that after the collision, both cars have the same speed at 5 meters per second. So what should you be looking for? This car will start out initially going faster, and this car will be going slower. And once they collide, you should see them traveling along at about the same rate of speed. So since this is me pushing the carts, it's not perfect, but you should definitely see what's going on. Try that again. So the front car is going slower, and then they both continuing along at a much slower rate of speed. Let's try that again, even slower with the front car. Pretty cool, right? So some of the momentum was transferred. Now I have a stopper at the end of this cart, and then if we hooked it up to the graphical analysis, what we would see for this last bit of the track is both cars would be recording about the same velocity for the end of the track. Okay, so momentum is always conserved, but we can transfer momentum from one object to the next during a collision. So take a look on page 69 at situation B. In this case, our blue car is going to be stationary, and our red car is going to be traveling at about 10 meters per second. So look what happens when the moving cart hits the stationary car. Again, we're working with the same train cars, the same mass, the same initial speed for the red car, and this car, because it's not moving, has 0 momentum. But once the collision occurs, then there will be momentum. So let's check out what happens when the red car, or the yellow one, collides with the blue car. So the momentum is transferred into the blue car. Did you notice that this car was moving slower after the collision? Let's try that again. So this one went from 0 and it gained all 10 meters per second. Now, if I had this set up correctly, this one would actually come to a stop much, much quicker. Okay, and finally, let's look at situation C. In this case, we have the 2 cards sticking together. So I had to take a look at that and make sure. So I have some magnets so that when these 2 cars hit, they actually stick together. So this time, instead of the momentum kind of being transferred through collision, when the 2 cards collide, they actually connect and become one object. And so what we end up doing is we combine their mass and they become one object with double the mass. So if this car starts out going fast, the picture shows 10 meters per second, and this car starts out stationary and they hit, the momentum is transferred, but because the mass essentially doubles, the speed should reduce by half. All right, so we should see this car going at a certain speed, and then together they'll travel at a much slower rate of speed. So let's try this out. All right. Perfect. Let's try it again. Awesome. So what we'll do next time is we'll build on this and we'll add the graphs that we can use with the Bluetooth wireless, and we'll look and see how the velocities compare before and after collisions, both collisions that are elastic and inelastic. See you next time.